Hello ladies and gentlemen, we are the Chem Connection. Today we are teaching you about combined gas laws.
Hi, so we will be doing the Erlenmeyer flask water balloon combined gas law experiment. So to set up this experiment, you want to have a tub, some sort of thing of ice cold water, and an Erlenmeyer flask, some sort of burner or heater that can heat it up. We're just using a pan. So what we did was we put 20 milliliters of water in there, and then you boil the water, and once the water is boiling, you are going to put the balloon on top of the flask. So Teddy will begin to proceed. Now the balloon is going to fill up with the air, and we're going to immerse it into the ice cold water. And as you can see, the balloon went from being inflated up here and into the flask. Now, how did that happen? That's a great question, Jack. I'll tell you exactly how it happens. First, the heating up the water in the flask causes the water to turn into water vapor. That water vapor is going to rise, and when you put the elastic balloon over that hole in the flask, the balloon actually traps that water vapor, and that will blow up the balloon. So once you do that, and you transfer it into the ice cold water, ice cold water, you put it in there, and the rapid change causes those water vapors that are rising to now fall back into the water, and that allows for the balloon to expand and have that space to expand. And since the pressure outside is now greater than it is inside the flask, it pushes the balloon inside, thus causing the balloon to blow up inside of the flask.
So before jumping right into an example problem, we must clearly define each variable. Our first volume was 20 milliliters of water in the flask. Our first pressure was 745 millimeters of mercury. Our first temperature was 298 degrees Kelvin. Our second volume was unknown. Our second pressure was at STP, which is 1 atm, along with our second temperature at 273 degrees Kelvin.
Okay, now we have to convert 745 millimeters of mercury into ATMs. So 745 millimeters of mercury divided by 760 millimeters of mercury. Then if you do that calculation, you'll get 0.980 ATM.
Now, after we found our new pressure, which is 0.980 atm, we can plug it into our combined gas law formula. So our first pressure is 0.980 atm times our first volume, which is 20 milliliters, all over our first temperature, which is 298 Kelvin. That's all equal to our new pressure, which is at STP, which is 1 atm, times an unknown new volume, all over 273 degrees Kelvin. Now, to solve for that new volume, we must cross multiply. Okay, after we do that, we'll plug the values into our calculator. So 273 times 0.980 times 20 equals 5,350.8. Now the other side of the equation, we have 298 times the new volume, which is unknown. We divide by 298. Divide by 298. We plug this into our formula to find our new volume. And we find that our new volume is roughly 17 milliliters.